Okay, so we're going to be talking about matrix multiplication, and I went ahead and just wrote the definition out for matrix multiplication before we got going here. And the reason I did that is it's a little involved here, and I want to highlight a couple things here as we go through this definition here. So first off, we have A as a matrix, and I want to point out here right away what the dimensions here are m by n, and then B is an n by p matrix. Then we have the product of AB. Now the dimensions of that, or the order, is m by p matrix, where A times B is equal to Cij, and then we have a weird formula for Cij. And it looks really complicated, but once we do some examples, you'll see it's really not as bad as you might think. Cij is going to be AI1 B1j plus AI2 B2j plus so on and so on until you have AIN times BNJ. Now, the other thing I want to highlight here is that matrix multiplication isn't always defined, because notice right here that this is n and this is n. Now, there will be an easy way to see this when we start going through some examples on when it's defined and when it's not defined. Now, what sometimes we think of this is it's row I times column j, and then we sum. That's what we're doing to get these c's. So I think the best thing to do is just to go through several examples of this, because I could try and talk about the formula more and try and put down arbitrary terms here and get it out a little bit more, but I think the best thing is going to be just to see some examples here. So let's start off with A is equal to -1, 4, 2, 0, 1, 2, and B is equal to 1, -2, 0, 7. Now, first off, we're going to, if possible, find A times B and B times A, because it's not always defined. Now, this is, again, something interesting about matrices, I think. If you're talking about just straight numbers, you can, of course, multiply in any order, and not only can you multiply in any order, you get the same thing. 2 times 3 is 6, 3 times 2 is 6. Alright, but we're going to see in this first example, you can't always do matrix multiplication. So let's first see how can we determine if we can do this. Well, write down one of the products that you want to do, A times B. Then beneath that, write the order or the dimensions of the matrix. So matrix A is what? 3 rows, 2 columns. So matrix A is 3 by 2. Then write down the dimensions of matrix B. Matrix B is a 2 by 2 matrix. Now, to know if it's defined, is it's these two numbers here have to be the same. For multiplication to be defined. So if these numbers in the middle there aren't the same, the multiplication's not defined, and your answer would be not defined. So that's the easiest way to determine whether you can even do the multiplications, is just write the multiplication of the matrices in the order that you're doing, and then write the dimensions down. And if these two numbers match, we can do multiplication. Alright, now what's the dimensions of the answer? Well, it turns out if we look at the outer two numbers, if we're defined, this is the dimensions of the answer. So the dimensions of the answer, that means we're going to have a 3 by 2 matrix as an answer. Now, of course, you don't look at the dimensions of the answer until you know you have your multiplication defined. So first look at the inner numbers to see if it's defined, then you look at the outer numbers to get the dimensions of your answer. Now that's really what is in the definition that we had at the beginning of this video. Okay, so let's write this down then here. So what do we have here? We're going to have negative 1, 4, 2, 0, 1, 2 times 1, negative 2, 0, 7. Now this is going to be equal to a matrix, and it's a 3 by 2 matrix. So I'm going to kind of put some blank spots here. This isn't necessary to do in your problems, but I'm just going to indicate, well, it's 3 rows, 2 columns, and so we have to compute 6 numbers here. Now, you heard me say that I'm going to do this kind of row times column thing. And what do I mean? Well, let's first go for this first element right here. So that's, in the answer, that's row 1, column 1. So since that's row 1, column 1, I'm going to underline row 1, and then I'm going to kind of to the right of it underline slash to the right of it column 1. It's always the row of the first matrix, column of the second matrix. Now notice that there's 2 numbers in the row, 2 numbers in the column. So we're going to pair the numbers up and multiply them together. So in other words, C11 is going to be negative 1 times 1 plus 4 times 0, which of course, that's just simply negative 1. So we get negative 1 in that position. And you can kind of see that's this row times column business. Now I'm going to erase those here because I've done the first one here, and now we're going to go ahead and move on to another one here. So let's go ahead and move on to this one. Now where's that? That's in the first row, the second column. So since it's first row, second column, I'm going to look at first row still, and then second column. So this would be C12 is equal to negative 1 times negative 2 plus 4 times 7, which is positive 2 plus 28, which is 30. So again, what we do here is we would write then that this is 30. Now we're just going to keep continuing on doing the exact same thing. So I'll erase these lines. And eventually you'll get used to this, so you don't even have to draw the lines. You'll just make sure that you're doing the correct ones here. And so then if I do matrix multiplication here, I'm going to now look, I just like to do them in order here, so I'm going to look at this one now. So that's row 2, column 1. So row 2, column 1, and so C23 would be equal to 2 times 1 plus 0 times 0, which of course is just equal to 2. So I have a 2 here. Now, hopefully you can start seeing the pattern here. I'm going to go ahead and erase these lines. And then I'm going to go to this one here. And that's row 2, column 2. So row 2, column 2. And this would be, well, wait a minute a second here. I said C23. This should be C21. Row 2, column 2. This would be 2 times negative 2 plus 0 times 7, which is negative 4. Now we're almost done. And so I would move to row 3, and of course row 3, column 1, this would be this row, this column, and so you'd have C31 is equal to 1 times 1 plus 2 times 0. 1 times 1 plus 2 times 0, well, that's just equal to 1. And it's still going to be row 3, but in this case, it's going to be column 2. And so C32 would be row 1, I'm sorry, not row 1, number 1 times negative 2 plus 2 times 7. So we have negative 2 plus 14, which is 12. You can see there's a lot of room for arithmetic mistakes on these. So this would be 12. So then we have the answer here, and I mean it's sitting right there, but I'll just rewrite it here, that A times B is equal to negative 1, 30, 2, negative 4, 1, and 12. Now, we do expect to see this work here for writing these down. So it seems like a lot, but we do expect to see it. And so now we still aren't done with this problem. We have to do B times A. So let's go ahead and do B times A then. So what do? We write down the multiplication I'm going to do, and then you write down the dimensions. So B is a 2 by 2 matrix, and A is a 3 by 2 matrix. But notice here, these don't match. Those inner two numbers don't match, so actually there's no work to do because BA is not defined, because we can't do that matrix multiplication. Alright, so let's look at another example here. So we're going to have A is equal to 3, 1, 2, 7, 0, negative 2, and B is equal to 6, 4, 2, negative 1. Alright. Okay, so we're still going to do A times B and B times A if possible. So let's first see if we can do A times B. So A is a 2 by 3 matrix, B is 2 by 2. So those don't match, so A times B is undefined. Now what about B times A? Well, this is a 2 by 2, and this is a 2 by 3, so these numbers do match, so it's defined, and then I also know that my result is a 2 by 3 matrix. So let's write it down here. So we've got 6, 4, 2, negative 1 times 3, 7, 1, 0, 2, negative 2, and this is going to equal, and I'm not going to put the blanks there, but it's a 3 by 2 matrix. Now I am going to write all the equations down, but I'm not going to draw the lines here. So let's first do C11. So C11 would be row 1, column 1. So row 1 would be 6, column 1 would be 3, plus 4 times 7. So this would be 18 plus 28, which is 46. So we get 46 here. And then I would do, again, I like to just do the rows first. You don't have to, you can do these in any order as far as finding the C1, C1, but it makes sense to at least do some kind of pattern so that, you know, it's a little bit more logical process. I like to do the rows first, a whole row and then another row. If you wanted to do the columns first, you could. Alright, so this would be row 1, column 2, so this would be 6 times 1 plus 4 times 0, which would just be 6. And then C13, row 1, column 3, so this would be 6 times 2 plus 4 times negative 2, which would be 12 plus negative 8, which is 4. Okay, well now we have the second row to do. So we have C21. C21 would be 2 times 3 plus negative 1 times 7. So 6 plus negative 7, negative 1. And then we'd have C22, which this is equal to 2 times 1 plus negative 1 times 0, which is of course just 2. And then finally for C23, we would have 2 times 2 plus negative 1 times negative 2. And so this would be 4 plus 2, which is 6. And so that would be our answer. I'm going to do one more example here, because so far the examples we've looked at have multiplication only defined one way, and that might make you question, can you ever do both A times B and B times A? And the answer is yes. In order for that to happen, they have to both be square matrices, as it turns out. But let's just look at a quick example here. 1, 2, negative 1, 0 for A, and B is equal to 1, 3, negative 2, 1. So let's do A times B. They're 2 by 2s, so I can definitely do all of the multiplication in either direction. So let's go ahead and write this down here. C11 would be row 1, column 1. So this would be 1 times 1 plus 2 times negative 2, which is negative 3. C12 would be 1 times 3 plus 2 times 1, which is 5. C21, negative 1 times 1 plus 0 times negative 2, which is negative 1. And then C22 would be negative 1 times 3 plus 0 times 1, which is negative 3. So writing down the answer then, this would be negative 3, 5, negative 1, negative 3. So I'm going to write this at the bottom here. And there's a very particular reason why I'm going to do that. Because we're now going to do B times A. Okay, so B times A is also defined. And this would be 1, 3, negative 2, 1. 1, 2, negative 1, 0. Okay, so then let's scroll up here. Same set of equations we got to kind of write down. So C1, 1. This would be 1 times 1 plus 3 times negative 1. Row 1, column 1. So this would be 1 plus negative 3, which is negative 2. C1, 2. Well, this would be 1 times 2 plus 3 times 0, which is 2. C2, 1. Well, that's row 2, column 1. So that would be negative 2 times 1 plus 1 times negative 1. And so, doing that, this would be negative 3. And finally, C2, 2. That'd be row 2, so negative 2 in column 2 times 2 plus 1 times 0, which would be negative 4. So I'm going to write the matrix here. So the answer would be negative 2, 2, negative 3, negative 4. So what I want to point out here is that even though I could do both A times B and B times A, notice that we get two completely different matrices. So matrix multiplication doesn't have any of the similar properties that we have with regular multiplication. Even if you can do both A times B and B times A, in general you're not going to get the same answer. Now it's possible to get the same answer, but not necessarily likely. So this wraps us up with matrix multiplication, and as I said, I don't think it's too difficult. There's a lot of tedious arithmetic that we have to do, but really I find that there's just a lot of room for making mistakes. And in the last several examples I wasn't drawing those lines. If you find drawing those lines helps you as far as like row and column, do that. I remember doing that when I was in high school and was first learning how to do matrices.